I'm going to set the stage just a little bit before we get into some other presentations. So we're here today to talk about wrong way driving. What is wrong way driving? Well, it's when someone decides either deliberately or inadvertently to go the wrong direction or the opposite direction of travel. As you can see in this picture, the car is going the wrong way. Sometimes we fail to remember, though, that these can be deliberate. A lot of what we talk about are the inadvertent ones and what causes that, and I'm going to go over some kind of high-level statistics today. But I think it's important to realize that there is a subset of people that may deliberately go the wrong way. So why do we care about wrong way driving? Well, wrong way driving has been an issue since the interstate system began in the 1950s. We've had research reports in the 60s and 70s about wrong way driving. We continue to see this issue come about, and even though it's a small segment of our crash population, it typically ends up in very severe crashes, as you see here on the screen. Two cars going at high speeds colliding head-on is typically fatal. We also are looking at these crashes because they do receive a lot of media attention, but also if we're going towards zero, if we're looking at reducing all crashes, we have to look at the small number of crashes as well as the large number of crashes. So I'm going to go over a few statistics that came actually from an ITE Journal article last August 2014. This is some data that they provided based on fatalities across the nation dealing with wrong way driving, so kind of set the stage from a national perspective. This is the average number of fatal crashes per year in the United States in the maroon color. It also shows the fatalities that resulted from those. In the gold or yellow color, you'll see how Texas ranks in the nation. If you were to look at Texas in a list of all the other 50 states, you would see that we're number one. Usually you like to be number one. In a college town, that's a good number. But sometimes when you're talking about safety issues, being number one is not the best. Now, we do need to remember that this is just pure numbers. This is not divided by a vehicle miles traveled or some other common denominator. But we do represent about 14% of the wrong way driving fatal crashes and then the fatalities. Nationally, where do these kind of crashes occur? You can see in blue the mileage, both rural and urban, and then again in like the gold color, you can see the number, or the percentage, of crashes in each of those areas. Again, these are fatal crashes. But you can see that representation in the urban area is much higher than the mileage. A little bit about the drivers that decide or inadvertently go the wrong way. As you can see, men in the audience, 2-1. Y'all are winning the wrong way driving award. Something to think about. You can also see an age plot here. While this study in particular did not break the age down but into 3 categories, what we can note on a national scale is the 15%, which is the individuals over the age of 65. On a national basis, across all types of crashes, they represent about 10% of the fatals. But when you look at just at wrong way driving, what they found in this study was that they represented about 15%. So we may have a tendency to have a slight overrepresentation from our older drivers. And again, that can be from confusion, disorientation. We also see these trends in Florida, and we'll talk a little bit about the Texas data in just a minute. And then the one I want to draw your attention to is the majority of these crashes are caused by driver impairment, particularly alcohol. And the number nationally for fatal crashes is 58%. There are other reasons. People do get confused, illness, etc., but that is the primary contributing factor across the United States. So what about here in Texas? This is just a plot of some data that we did a few years ago for TxDOT that shows you where the wrong way driving on freeways are. Now, these are not just fatals. Our analysis included injury as well as fatalities. So we have a little bit larger sample size than the national study I just was referencing. But this gives you a kind of a visual. I'm a visual person, so I like to kind of see it in a picture. Just real quick, how do our Texas drivers match up? Well, we're about the same as far as male to females are concerned, but in the Texas data, we were able to look a little bit more closely at the age categories. And what we can see is the majority of them are from age 16 to 34. And again, a lot of those tend to be male. In particular, about 50 some odd percent, I can't remember exactly the right number right now, but almost over half basically are in that age range from 21 to 34. So it tends to even be a younger male issue. When do they occur? I know a lot of you may have seen a graph like this before, but it's always interesting to point out. They occur all the time, but we tend to have a very evident peak around 2 a.m. And what happens, audience participation time, what happens at 2 a.m. in Texas? There we go. So we tie it back to our impairment issue. So these are the statistics on some contributing factors for here in Texas. You might say, well, why is it only 36% for alcohol here in Texas? We just saw 58. Well, you have to remember that study was just looking at fatalities. So alcohol may have represented a larger portion of their fatalities they were looking at. This is looking at Texas, and we're looking at all the severity of crashes, and it was 36%. But it still is the top contributing factor. Distraction is the 16% shown here. And then as I mentioned earlier, illnesses, medications, those kind of things also have a percentage. That's 3%. All other things were under that percentage. They're in the 1 to 2%, but there are some other contributing factors. So in some of the data that we were able to extract a few years ago, we actually pulled the blood alcohol concentration levels for those that are reported. They're not always reported. The big red vertical line here is the legal limit in Texas, 0.08. What you can see is that over 90% of those that were in a wrong way crash on a freeway had a BAC level higher than the legal limit. What you can also see, let's see if I can get the, oops, I went on to the right one. I'll let you do the looking. I can't figure out the, oops, sorry, I'm going the wrong way. The laser right now, but if you look over to 0.16, which would be twice the legal limit, if you go up and go over, you can see that was about 50%, and if you keep going over to 3 times the legal limit at 0.24, you can see that represented 90% of the individuals. So we're not always talking about people that may be slightly or just at the legal limit. We're talking about people that can be very intoxicated that are choosing to drive. And so I think this is important to point out that while there are a lot of engineering countermeasures, we have to bring other people along with us. We have to bring enforcement along with us, and we have to bring education along with us, because just educating drivers about the dangers of driving while intoxicated will impact this number as well as many other things. So briefly, I just wanted to talk about a few projects that we recently completed or are ongoing, just so you have the knowledge of them. We did do a project that ended last August for TxDOT that looked at engineering countermeasures. And while I'm not going to give you results from that today, there's a link to the study here, but I will tell you we had a lot of fun because we actually got people intoxicated and let them drive a car. That's always fun. So if you want to talk about that later, we can. But we were trying to look at how those people drive, how they see sign color, how they read signs, how they interpret messages, so that we would understand the processes going on while they're trying to driving at an inebriated level. We also looked at various countermeasures and did some field testing and assessments, and then we also looked at what we should post on dynamic message signs with regard to warning right-way drivers about the possibility of a wrong-way driver on that road. And so I encourage you to check out that report, and you can always ask me any questions on that. Currently, we have an ongoing project with TxDOT to kind of look at the next step. So as I mentioned earlier, there are several innovative and traditional engineering countermeasures that we can implement to combat wrong-way driving, but we also have to look at detection, notification, and maybe even connected and autonomous vehicles. That's kind of the next leap, because we do have those that are so intoxicated that our traditional measures or even some innovative engineering countermeasures may not get through to them. So on this project, we are in the process of developing a concept of operations, functional requirements, as well as high-level system design for a connected vehicle test bed that would evaluate wrong-way driving applications. And so that is, phase 1 has been ongoing for several months. It will be completed in December of this year, and then we will decide where to go with that next. TTI is also leading a team and doing a NCHRP project dealing with wrong-way driving. This one is back to looking at some of the engineering countermeasures, but particularly looking at freeways as well as this time divided highways that are not freeways. So a lot of the research has been done on limited access or controlled access freeways, but we also have divided highways. And the question has come about of how does the width of that median play into what countermeasures you may put up for wrong-way driving so that the person knows not to take an immediate left into oncoming traffic. And so we're going to be doing some crash and safety analysis to look at that issue, and also then just to look at the implementation of different countermeasures for freeway exit ramps. And all of that is a culmination just to look at what's in the MUTCD, what maybe doesn't. There is some inconsistencies in there right now, what maybe needs to be added or changed in making those recommendations. And last but not least, I just want to touch on a couple of innovative things that are happening in other states, again, just so you are aware of those. We should hear in a little bit from Dale about some of the implementation on US 281 with LED border illuminated signs, but they are also being tested in other states. Specifically, Rhode Island has outfitted 24 exit ramps with this sign plus the detection system, and they're evaluating that. We're having discussions with them, maybe on the possibility of helping them with that evaluation on the NCHRP project. We also have the University of Central Florida, who's evaluating 17 exit ramp locations in South Florida with these devices. So it'll be good to see the results that we keep coming in and updating from the San Antonio area, but to compare it with other locations across the nation. Another innovative countermeasure that's being implemented in Florida is actually using red, rapid rectangular flashing beacons above and below the wrong way sign. This is in conjunction with a detection system. They have outfitted them in 2 locations, 6 exit ramps around Tampa and 5 ramps in Central Florida. And there are 2 universities there that are helping evaluate those systems. And again, those are under request to experiment in Florida. Florida and California are also looking at implementing in-pavement lights that would be illuminated, not just your reflective RPMs. And they're in the process right now, very infant stage of looking at what designs they may want. This is just a rendering from one vendor that you could just do the standard arrow. There are some questions on whether you could put an X in the lane. There's questions on just putting a bar, like a stop bar. So there's various ideas out there, and it'll be good to keep up with them and see what they're doing in that area and to follow the results that they have. Also, I recently learned about a system that is similar to the others, but instead of having LEDs embedded in the sign, this system has an LED what they're calling flasher bar. It is red LEDs, it's not illuminated in this picture, but the little black segments on both sides of that sign have red LEDs in them, and so they would activate when a wrong way car was detected. Again, it has the detection system, notification system, but this one was recently put in. Arizona DOT is going to put this in 15 locations. They just recently released a purchase order for these. So again, just a couple of different innovative countermeasures, things that take a step beyond the traditional that I thought y'all might have some interest in knowing were out there. And that's all I have this morning.